Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Erosion of the Carolina Bays. This LiDAR image shows the transition zone between the Atlantic coastal plain and the rougher terrain further inland. Carolina Bays have been preserved mostly on the porous flat soil of the coastal plain. The mathematically elliptical geometry of the Carolina Bays and the Nebraska Rainwater Basins suggests that they originated as inclined conical cavities formed by oblique impacts of glacier ice ejected by an extraterrestrial impact on the Laurentide ice sheet in the Great Lakes region during the Ice Age. The Nebraska Rainwater Basins are found in sandy deposits along the Platte River. The Carolina Bays are found on the East Coast from New York to Florida, but they are most evident in North and South Carolina. The yellow line in this map indicates the approximate seashore during the Ice Age when the sea level was 120 meters lower than today. Many Carolina bays have vanished under the sea. Michael Davies established a database of LiDAR images available at syntos.org. The database integrates with Google Earth and provides a convenient way of doing research on the Carolina Bays and the Nebraska Rainwater Basins. The topology of the LiDAR images is enhanced with colored contour lines. The blue contour line highlighted here corresponds to 50 meters above sea level. The distance between the 50-meter and 60-meter contour lines is approximately 11 kilometers, which is a change of elevation of only 10 meters in 11 kilometers. The terrain is virtually flat. The distance between the 60 and 70-meter contour lines is also about 11 kilometers. However, the distance between the 70-meter and 80-meter contour lines is 9 kilometers, which is a slightly steeper grade, but still very flat. At the boundary of the elevated terrain in the coastal plain, the 10-meter contour lines are separated by only 1.5 kilometers. This image shows that the Carolina Bays are present on flat terrain, but not on the rough terrain. We can zoom in with Google Earth on this LiDAR image. We start from a point of view higher than 100 kilometers and we gradually go down to an altitude of about 5 kilometers near Bowmore, North Carolina. In satellite images, the vegetation obscures many of the Carolina Bays that are very clearly defined in the LiDAR image. The rectangle that we saw in the LiDAR image is an array of 8 farm buildings covering an area that can fit 7 football fields. The preservation of the Carolina Bays can be explained by the way in which water drains. In level terrain, rainwater cannot flow fast horizontally along the surface, so it percolates through the soil and then flows toward lower terrain via underground aquifers that eventually lead to the ocean. The slow horizontal flow of water on the surface reduces erosion of the Carolina Bay features, especially if the terrain has grasses or other vegetation that stabilizes the soil. On inclined terrain, rainwater flows downhill, but some water also passes through the soil to underground aquifers. The flow of water along the surface is turbulent and erodes the sandy soil, eventually erasing the features of the Carolina Bays and Nebraska Rainwater Basins. This image shows the flatness of the terrain in the coastal plain. Hurricane Florence brought heavy rains to North Carolina in 2018 and caused extensive flooding. The terrain is fairly level, so water flows very slowly along the surface, which minimizes erosion of the Carolina Bays. The water eventually percolates through the ground and is carried toward the ocean by underground aquifers that connect to streams and rivers. The level terrain and the porous ground have contributed to the preservation of the Carolina Bays for approximately 13,000 years, but deforestation, agriculture, and urbanization have made the terrain less resistant to water erosion. Strangely enough, there are some flat areas in hilly terrain where Carolina Bays have defied erosion. This small island of Carolina Bays is situated between Milledgeville and Sparta, Georgia, 240 kilometers inland from the Atlantic coast. The flat section with the Carolina Bays has an elevation of 180 meters above sea level, which is 80 meters above some nearby fluvial channels. Zooming in from an altitude of 100 kilometers shows the remarkable isolation of this group of Carolina Bays in Georgia. It is quite possible that at one time this area was completely covered with Carolina Bays and they have slowly eroded away. The transition zone between high terrain and flat terrain has bays that differ in shape from the elliptical geometry. Bays in the transition zone were distorted by mud flow during their emplacement. Their shape was not modified as a result of erosion. The bottom portions of these bays still have elliptical geometry, but the portion against higher terrain was modified. The inclined terrain conditions can be simulated by tilting an experimental container during viscous relaxation. The diagram on the lower left shows that a conical cavity on inclined terrain has a steeper inclination on the uphill side that allows increased mud flow, thereby creating the distortion. We now shift our attention to Nebraska. The Nebraska Rainwater Basins occur 670 meters above sea level on ancient sediments along the banks of the Platte River. The broad rainbow arch corresponds to more recent alluvial deposits from the Platte River. The terrain in Nebraska is rougher than the Atlantic coastal plain, and this has caused the erosion of most Nebraska rainwater basins smaller than 4 kilometers. A satellite view of the Nebraska landscape shows only square farms and circles made by center pivot irrigation systems. A LiDAR image of the same area shows the square shapes of the fields, but it also reveals the elliptical shapes of Nebraska rainwater basins. The field survey by Michael Davies identifies the location of the basins, their size, their shape, and their orientation. LiDAR images provide visualization of the surface of the Earth that makes it possible to consider new ideas about the mechanisms that form the Carolina Basin and the Nebraska rainwater basins. Any study of the Carolina Basin is incomplete if it does not also consider the Nebraska rainwater basins, because even though these geological features are separated by more than 1,800 kilometers, they share the same elliptical geometry and a radial orientation that converges at a common point by the Great Lakes. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.